The Data Mining and Machine Learning Laboratory. My name is Dr. Tagi Koshkoftar. I'm the director of this lab. We have two labs together in one place. One is Empirical Software Engineering Lab and the Data Mining and Machine Learning Lab. These are the projects that we look at during the last 5 years. The first one is ocean exploration. The ocean exploration, we have look at the mining underwater images, analysis and processing of videos, content-based image retrieval, detecting objects of interest, for example, drug discovery and other things for cancers and other diseases. And this project, that ocean exploration project, that we had a grant that from FAU Center of Excellence in Biomedical and Marine Biotechnology. Second project that you see under that, coastline security. This is again was 3-year project, that coastline monitoring system, that mining of surveillance videos, processing underwater videos, identifying object of interest, and intelligent data analysis. This project was funded at Office of Naval Research. Network security, that another project we worked at for 2 years. Network intrusion detection, look at intrusion in wired networks, intrusion in wireless networks, network traffic measurements, and advanced data mining. And this was funded by the Department of Defense. The next one here, the software engineering. This is very important area that we have worked at during the last 20 years or so. We look at many projects, software measurements, software quality estimation, software risk assessment, software cost estimation, testing, verification, and so on. For related to this, that we have a current project that the testing and verification of web services. Intelligent computing, which is a general word that we use all sorts of tools and techniques and algorithms to solve the problem. Software development, that whenever we are working on a project, at the end we have tools. Here you see what a sample of those things that we have achieved that during the last 5 years or so. One, we developed that content-based image retrieval system, that we developed this, and this is part of the Center of Excellence project. Developed software measurement, analysis, and reliability toolkit that we work with NASA. Also rule-based modeling toolkit with empirical simulation prototypes. That's, these are just sample of the things that we developed. The sources that we have, as I mentioned, that FAU Center of Excellence, that in biomedical and marine biotechnology, we had 3 years project with them. The Department of Defense 3 years, Office of Naval Research 3 years that we had with them, different times of course, and the National Science Foundation, and also NASA software, IBMV means verification and validation center. These are the project we worked at. Over 350 referee journal and conference paper. More than 60 PhD students and master students written thesis and dissertations, and several industry partners we had that, and several academic collaborators as well. So as you see that we have 2 labs together in one place, 2 kinds of research, one related to software engineering general, which we have many areas within the software engineering, and the other one, that data mining and machine learning.
Hello everyone, my name is John C. Sloan. I'm a PhD student here at FAU in the Empirical Software Engineering Laboratory. We've had the opportunity to look at not only testing but formal verification of service-oriented architectures. For one, we're looking at the application of formal methods. The second area has to do more with the looking at a web deployment of this formal verification. And in the process, we are looking at certain very big computational problems having to do with mining of state spaces in a model checking context. And that data mining problem can perhaps best be distributed over the internet via a volunteer supercomputing architecture. The third area are agents, and the use of agents in what I would like to term a semi-formal verification of service-oriented architectures. Our fourth area of research would be trade-offs, formal within the area of validation, are we building the right system, and verification, is the system doing its mission correctly? What we're going to look at is focusing in on just one of these research areas. We've, in our research, have used two tools. The first one we're looking at is something known as CPN tools. Each provider, for example, there can be tens of thousands of instances of providers and tens of thousands of instances of users. So this is a big model. So in order to focus more in on the timing issues, we had to abstract greatly from that model. And now we have simply a two-party interaction. Here, a web service portal and a set of workers that are providers of computing cycles for the portal. This formalism, whereas the previous formalism we had was something called a fair transition system, namely a PetriNet, this is represented as a timed automata.
Hi, my name's Omri, and since I've been here, we've been focusing on a problem in the subdomain of data mining called classification. Examples of some target concept that you want the computer to learn and be able to discriminate between multiple categories of these examples. So an example is you want to detect credit card fraud, for instance. You have a bunch of attributes about each example of a credit transaction, you know, how much it was for, where it was from, the date, things like that. And then you have a dependent attribute, which is the class. It's a categorical variable. In this case, it would be whether or not it was a fraudulent transaction. And so in classification, you try to build a program with the computer that will discriminate between these multiple classes. And a lot of real-world problems where you would apply classification, you have the problem of what's called class imbalance. So when most of the examples in your data set that you're learning from have one class, and then there's only a small number of the other class, it biases most machine learning algorithms. So those are some of the important application areas where you know, there's class imbalance. Another problem in data mining is quality of data. The better quality your data is, the better model you're going to be able to create to make more accurate predictions. So in our laboratory, we do a lot of empirical research, very comprehensive experimentation to size, etc. We perform many repetitions so we can get a good sense of the statistical significance of our results. So fortunately, we've had the use of several supercomputers and computing clusters, and we've been able to get a lot of work done. And you know, I think it might be safe to say that in the area of class imbalance, we're probably maybe the foremost authorities in the world on practically how that affects classification and which techniques work best.
Okay. The third presenter is Shah Yuan-Su, who's going to defend his dissertation that in a few hours, that this is another application of the data mining and machine learning in the area of internet and web.
Hello, my name is Shah Yuan-Su. I'm a PhD student of Dr. Koshkovta. Because the objective of Calibrate filtering is to make accurate prediction for incomplete data. Online shopping websites, such as on Amazon, when we log in, we'll get a list of recommendations from the website. And when the recommendation is accurate and satisfactory, the customer will be most probably add that to the shopping cart and check out. The idea is to find the nearest neighbor or most similar users to the current customer. We make the recommendation for the current customer. I believe our research have already attracted interest on this for the research in this area. Also attracted interest from the industry.